when you have a side, and an angle, you could possibly get two triangles. Or you might just get one triangle, or you might end up with no triangle at all, okay? So because of that, this is called the ambiguous case. Ambiguous meaning we don't know what we're going to get until we analyze it a little closer, okay? So for the no triangle option, what ends up happening, let me just visually show you what's going on here. Let's suppose we're given information for our triangle, and the information that we're given includes an angle, a side, and a side. But let's suppose that that side that we're given is too short to reach to even make a triangle. Okay? We might be able to figure that out by the thing I told you about today, that if you add the two sides together, they should be greater than the third side. However, do we even know the third side? No. So we don't know that that's going to happen. We can't do it the geometry way by just saying, oh, two short sides added together are not bigger than the third side, so there's no triangle. We actually have to have a different way of figuring this out. In order for side A to be long enough to reach down and make even just a right triangle by stretching straight down and making a right triangle, it would have to follow the SOHCAHTOA formula, where this would be sine opposite over a hypotenuse, right? It would have to fit the formula sine alpha equals A over B in order for that to even be a right triangle. And side A would even need to be longer than that if it's an oblique triangle. So this is the shortest possible length it could be and still work, right? So let's go ahead and think about cross multiplying. In order for that to even be a triangle at all, it would have to be A is equal to sine alpha, or B times sine alpha, right? But what if A is shorter than that? Like in my picture here, what if A is too short for that to be equals? Yeah, it's not a triangle. So there's no triangle if A is less than B sine alpha. Now here's the tricky part. Are the numbers you're going to get, are they always going to be alpha, A, and B? No, they might be labeled other things. It might be gamma and C and B, or gamma and C and A, or it might be beta and B and A, or beta and B and C. But it's always going to be a side, and an angle. So in order to use this little test, you just have to figure out, you're only given one angle, so that goes there obviously. And the side that's across from that angle goes here. And the other side that's next to the angle goes here. You don't have to get stuck with using A, B, and alpha. Does that make sense? That's just my way of illustrating it. So the first thing you always do when you get an SSA triangle is you do this little test, because it will immediately tell you whether it's going to be no triangle, one triangle, or two triangles. Okay? In order to get one triangle, it ends up being a right triangle, and that's kind of what I just barely got done explaining. If it's just barely big enough to stretch down to that point there, it's going to make a right triangle. So that's when A equals B sine alpha. Okay, and then the two triangles is actually when A is too long to just go straight down. So instead, since A is longer than just long enough to go straight down, it's longer than that. In order to get it to fit, it either has to swing that direction and make an obtuse triangle, or swing that direction and make an acute triangle. And that's where we end up, or it might be obtuse depending on what that angle is. But the fact is, it can make two triangles depending on where you put it. If you swing it that way, because it's longer than a right triangle would need to be, you get that triangle. Or if you swing it that direction, you get this bigger triangle instead. So you can have two different possible triangles. So that's when A is longer than it needs to be. to reach straight down. Has to swing one way or the other because it's too long to go straight down, right? So it's greater than. Then it's actually possible to get one triangle another way. In all of these cases, what have you noticed about my drawings with A compared to B? Notice the length of A compared to the length of B in all of these drawings. A is shorter than B in all of these, right? So A is shorter than B in all three of these situations. So in this case, A is the one that's across from the angle. So if the side that's across from the angle is shorter than the other side, then you have to test it. But the last situation is, if A is longer or equal to B, then there's only one option. Because here would be alpha, here would be beta, and so there's like only one place A can go. A is either going to come down and make a right triangle or just stretch out to where it has to be. Do you notice how this time, because A is longer, there's no way that it can do this little flip back and forth thing to make your two triangles? It's kind of just stuck in one place. So that would just be one possible triangle. Okay, so there are 4 different possible situations. 2 of them are one triangle. 1 is 2 triangles, 1 is no triangle. And you have to test SSA triangles before you start to solve them. Because if you don't, you might start solving it and either you get an error and you find out it's no triangle, so you've wasted time trying to solve something that can't be solved, or you end up getting one triangle answer and you think you're done, when in fact there should have been 2 answers, and then you miss half of the points on that problem on your test because you didn't check to make sure that there was only one triangle instead of 2. How does that sound? Okay, let's do this quick one example first. So let's sketch a triangle if you want. We've got alpha, we've got side A, and we've got side C instead of gamma. So I would say always start with your angle, whatever it is, and just put it over here so that it lines up the same as my pictures. So even if it's not alpha, if it's beta or gamma, still put it in the same place. So this one I'm going to put, it happens to be alpha, so right there I'm going to write 65. And then side B, or side C is what it is 8. But that's what's going to go in for B in these formulas. It just happens that they gave us C instead. And then we don't know exactly what A is going to do. We might not want to draw it until we're done so that we know what it's going to look like. But the fact is, side A is over here somewhere making either one triangle or no triangles or 2 triangles, correct? So what do we do first to test this? What letter is coinciding with A in the formulas? A. It still is A. Okay. What letter is coinciding with B in the formulas? C is. What letter is corresponding with alpha in the formulas? Alpha. So we're going to do 8 sine 65. So put that in your calculator. 8 sine 65. What'd you get? Okay, so how is side A related to that number? It's less than. What does that tell us? It's too short to make any triangle at all. So what's the answer? There is no triangle for this particular problem. So once you've figured that much out, you don't need to solve it because it's not solvable. Alright, I'm actually going to start a separate video to do our 2 triangle option.